All right, here we go. The next thing we're going over is parallel and perpendicular lines. All right, so let me show you guys. See this okay? All right, so first thing I'm going to do is just basic parallel lines. Remember, parallel lines have to have the exact same same slope, different y-intercept. So by definition, are these parallel? Yes, their slopes are identical, their intercepts are different. So very easy, yes. Now I got to do some work to see if these lines are in fact parallel. I got to move this guy around into slope-intercept form. So I'm going to add 16x to both sides. And now I got 4y equals 16x minus 8. And I'm going to divide both sides by 4, and I'm going to get y equals 4x minus 2. Are these parallel? Not at all, because they are in fact the exact same line. So the answer to this is no. Okay? Got those right there. Remember, they got to be same slope. They got to have different y-intercepts. So make sure you're doing your math correctly. Over here, same thing. I got to see if this looks like this with a different y-intercept. So let's just do our math. Put this into slope-intercept form. So this is 2y equals negative 4x plus 6. I'm going to divide both sides by 2, and I get y equals negative 2x plus 3. So is this? No, it's not, because these slopes are different. Therefore, they are not parallel. Remember, different slope, same slope, different y-intercept. Now down here, are the following lines parallel? So remember, our rule of parallel is reciprocal opposites. If it's positive, it's negative. Flip the numerator to denominator. Did my slopes have a reciprocal? Yes, this one's positive, this one's negative, so the answer for this one is yes. Very basic. These are reciprocal opposites because we don't care about the y-intercept. All we care about is the slopes for perpendicular lines. Over here, again, just look at it in basic and understand. Are these reciprocals? Yes. Are they opposites of each other? Is one positive, one negative? No. Therefore, these are not perpendicular because of that one fact. Over here, we got to do a little bit of work. My slope is 1. My reciprocal opposite of 1 happens to be negative 1. Remember, 1 is 1 over 1. Flipped is still 1 over 1. So just the opposite of that is negative. So let's do some work. I'm going to add 3x to both sides. I get 3y equals 3x plus 6. Divide both sides by 3, and I get y equals x plus 2. And that is a positive x, just like this is a positive x, so the answer for this one is also no. I'll be back in a minute with some more examples. All right, my next two examples for parallel and perpendicular lines have to do with this. The first one says, find the equation of a line parallel to y equals 3x minus 5 and has the point 4, 14. So this is as basic as we know the rule with slope. All we got to do is find the actual equation, so we got to find that y-intercept. So remember, we are just rewriting this equation, y equals 3x plus b, rewriting x and y with these 2 points. So 14 equals 3 times 4 plus b. 14 equals 12 plus b, subtract 12 from both sides. So my b equals 2, so the equation that has this point and is parallel to this line happens to be y equals 3x plus 2. There's that first one. My next one is right here. Find the equation of a line perpendicular to y equals 3x plus 8 and has the point negative 6, 4. First things first, follow the rule of perpendicular lines. The reciprocal of 3 is 1/3. The opposite of 3 is negative 1/3 x plus b. There's that first piece. Now the next is just do the same as we did before. Replace x and y, solve for b. Y happens to be 4 times negative, or equals to negative 1/3 times negative 6 plus b. Negative 1 times negative 6 is positive 6. Positive 6 divided by 3 is 2. So 2 equals b, minus 2 minus 2, 2 equals b. So the equation of the line that's perpendicular to this is y equals negative 1/3 x plus 2. Okay?